Good morning, everyone. Ellargu namaskara. On behalf of Department of Collegiate and Technical Education, I welcome all the students to third semester Electronics and Communication Engineering course. This is an initiative of Department of Collegiate and Technical Education to develop e-content for all the courses of engineering in Karnataka as per the VTU syllabus and to provide a platform for all the students to learn. So we would like to extend our thanks to the Commissioner, Department of Collegiate and Technical Education, and all the other office bearers for helping us to develop this content. I am Professor Krishnananda, working at Government SKSJ Technological Institute, Bengaluru. I will be handling this subject, Computer Organization and Architecture, for third semester engineering course. I'll be taking you through the module 1 of this particular course. Now, this subject has been divided into 5 different modules, and each module will have certain content to discuss, and each of those contents will be discussed in depth to make your learning much better. So before going into all the details, we will just look into the contents, what is discussed in this particular session, what we are going to have now. So introduction, basic structure of computers, the types of computers, function units of a computer, and terminologies. So the first topic would be on introduction to this particular subject itself. So why this subject has been placed in the third semester to help the students to understand. This subject acts as a prerequisite for higher semester subjects like microprocessors, microcontrollers, embedded systems, etc. This is one of the prerequisite for higher semester subjects. So that is why the subject has been kept in third semester. And the main course objectives for this subject would be to understand the basic structure and functional units of a computer, their organization and operation, and illustrate the concept of assembly language programs, machine instructions, sequencing, how to write programs, and other aspects of programming. The third module in this subject would be discussing about interfacing and communicating with different types of input-output devices, commonly known as I/O devices. That means how do we interface different devices to a computer and then operate with it. The fourth module in this subject would be with respect to the memory design. All of us know the memory plays an important role in your mobile phone or any computing gadget. So how do we design memory and how do we understand the architecture of memory and all? We will be discussing in module 4. Finally, in module 5, we will discuss about internal organization of the CPU itself. CPU stands for Central Processing Unit. We will be discussing that again later in the section. So this particular subject has been divided into 5 modules with these course objectives. Now coming to the course outcomes. So whenever we talk about outcomes, it is almost always at the end of the course. So at the end of the course, students should be able to explain the basic structure of a computer and basic organization of a computer, and also need to explain how do we access and communicate with I/O devices. So should be able to explain and illustrate the operation of different types of memories and storage devices used in the computer. And students should have a knowledge about how a processor works, what is the internal structure of a processor, and how the processor has been designed with these different control unit operations. Okay, this is the basic overview of this entire subject. Now coming to the module 1 in this particular thing. The module 1 is basically with respect to the definitions and the operations of, in general, a computing system. So for that, we will try to look into 2 important definitions as we are seeing here: computer architecture and computer organization. Computer architecture is dealing with the structure and behavior of the computer. Now, we all know an architecture. For example, if we look at a building, we say, oh, a very good architecture. That means we look at the outside structure of that and how the different building blocks are there. So everything we will know, but we may not know the working of that particular thing. So to know the working of the architecture, the building blocks, we need to go for computer organization. So it refers to the logical aspects of this design process or the implementation of this particular architecture. So computer organization and architecture is a full-fledged course in third semester electronics and communication engineering. And as you all already studied, maybe in first semester or second semester, C programming subject, there also would have studied little bit about computers hardware. So just to recall your basic knowledge, I have just given you here a diagram illustrating a normal desktop computer. What are the different parts of a desktop computer? You know that there is a motherboard, there is a video card, there is a fan and heat sink for your CPU to dissipate the heat, and there is memory module, there is a power supply, there is your DVD or CD drive or whatever the external device, and then there is a hard disk which is used to store the data or the information required by the user. So this is the general structure of a computer, just to make you recall your first semester or second semester C programming course where you studied a little bit about computers. Okay. So in module 1, we shall look into the basic structure of computers. Okay. And how the instructions can be used to do that. We will discuss all those things in detail. So let us not worry about all these definitions in the beginning now. So and we have divided this module into some 7 sessions. So in each session, we'll be discussing a little bit of topics in depth. So it becomes easy for all of you to understand what we are discussing and what we are actually going towards the next sessions. Okay. So in this particular session, the first session, we will start with types of computers, the functional units of a computer, and the overall operation of the computing system. And most importantly, some of the terminology is required, because most of you, maybe in your 10+2 or something, you would be making with a biology background. You might not have studied computers or electronics in PU. If you already studied, it's good enough. Otherwise, also, we will teach you from the basics so that you will not have any difficulty in this. Okay. So let us come to the types of computers or the classification of computers. So as you all know, most of you anyway, because of COVID now at home, and most of you are using some kind of laptops or tablets or some kind of devices to uh, study and understand, right? So from the beginning, as we all know, from 1980s, the computers have started coming into the market from around 1980s. So from that till 2020, almost now 40 years. So we had a bigger computer evolution, as we all know, especially in the last 10 years or so. So from the beginning till now, what are the different ways of designing and how the computers are coming to the market. So the types of computers, as we all know, like for example, desktop computers, which you all are familiar with in your, maybe in your laboratories or in your schools and offices, which you are able to see. Even on my backside now in the video also, you can see these desktop computers in our college, right? And there are then your laptops called as technically called as notebook computers. Then there are workstations which can carry out higher level jobs, and there are enterprise systems which are used as servers in commercial organizations like Infosys or Wipro or any such or any other big organization. Then we have supercomputers. You would have heard about this, like for weather monitoring and very fast operations, we need these supercomputers. And today we have all these small portable devices, as you all are aware of. In your school days, you would have used, or now at least you may be using the Kindle, the tablets, the e-readers and all, which will be useful for doing a specific set of tasks on the go. In the sense they are portable, you can carry them, they are lightweight, whereas a desktop is a little bit difficult to carry here and there. So you can do all the computations and work online kind of a thing on the go. So these are the different types of computers which we would be knowing now. So coming to what actually makes a computer, like what is the actual, the functional blocks of a computer. So you can easily see here what we are showing here. So the main part of the computer brain is this, which is called as CPU, which is here written Central Processing Unit, or technically known as processor. The another important functional block is, of course, memory. Then we have input unit and then output unit. So these 4 blocks together make a block diagram of a computer. Okay, a memory, the input output unit, the CPU or the central processing unit. And technically, all these physical parts of a computer are generally known as hardware of the computer. Okay, physical parts which you can touch, feel, which you can use it for your purposes, are generally known as hardware of the computer. Okay, hope this much is understood for you. Now coming to the definitions of this and why they are used. For example, the question in the exam can be explain the functional units of a computer, maybe for 4 marks or 6 marks like that. Then you are supposed to write this diagram and this explanation what we are trying to do here. Okay. The processor or the microprocessor, technically called as, are generally known as CPU, generally known as CPU. All are same, okay? They are synonyms. Processor, microprocessor, or CPU, they are synonyms. Okay. So it's the brain of a computer performing all the arithmetic and logical computations. So how we define CPU, we'll discuss that later. The time being, you can think it as a programmable digital integrated circuit. An integrated circuit is also known as IC in shorter form, or in general form is known as chip. In basic electronics subject, you may study about this in detail. What is an integrated circuit? For the time being, you just understand that this is a hardware device having some pins on it, and then it will be using some voltage to operate. So you need to supply some power to operate this. Okay. What is the definition of this programmable and all? We will discuss later. Okay. Now, second functional unit of your diagram was memory. If you look into the previous diagram, so it is a storage device to store your instructions and data. It's a simple definition for you to understand. And there are two types of memory: primary memory and, of course, the secondary memory. Primary memory is having lesser capacity, it is fast, whereas secondary memory is having larger capacity and it is permanent storage, but it is little slower compared to the primary memory. So examples also I have written here. We will discuss, as I said earlier, each of these things we will be discussing in detail in later modules. Okay, whatever is required to give a smaller definitions and the terminologies here I'm trying to provide. In each module, when we go ahead, we will discuss this in detail. Okay. So the example of primary memory is like RAM or ROM. Example of your secondary or a auxiliary memory is your magnetic disk, your hard drives or SSDs, CD, DVD, etc. Now, the third important functional unit of your computer, what we have seen previously in the diagram, was the input output devices. Now, basically, these are the interfaces of your computer to the external world. In the sense, what, of course, you are sitting in front of computer is there, but you need to give some data, right? So you need some input device to give your data. Or let us say you take an example of say a temperature monitoring system in a hospital or something, in an ICU or something like that. Then you have some sensors to monitor the temperature or measure the temperature. That is an input device. So like that, there can be different types of input and output devices in a system. So we all are familiar with this. You can see keyboard, mouse, microphone. Like for example, I'm speaking now with a microphone. That's an input device, right? A camera or a sensor or something. These are all input devices. Similarly, examples of output devices. For example, your monitor in your computer itself is an output device. Your printer is an output device. Or in railway stations and all, you see displays with LEDs, LCDs and all. They are all output devices. So there are a lot of practical examples which you can only think of for input-output devices. So the question would be, explain the functional units of a computer with a block diagram, maybe for 4 marks or something like that. So just write this diagram and make this explanation. You can write in your own words as well, own sentences, and give proper examples for each of them. Okay. Now, some of the terminologies which we will be discussing now, just to understand the basic concepts. Again, I'm repeating this because in detail, every module we will discuss later. Okay. So what's a computer now? A digital electronic device which is capable of performing a set of operations as per the requirements of the user. Okay. This is generally called as a digital computer. Okay. Now, what is hardware? The hardware is physical parts, as I said already, like your mouse or keyboard or monitor or motherboard or memory CPU, which you can touch and feel and use for your operations, is known as hardware. Then coming to the next terminology, which is instruction. Instruction is basically a command issued by the programmer or the user to perform a basic operation. How do we give instructions in general? As we know, for example, inside a class, if a teacher asks someone to stand up and answer, then that is an instruction to that student that he should stand up and answer something. So That kind of a command needs to be given to the CPU also to perform. Suppose you want to perform addition or multiplication or something else, whatever you want to do. So that is how you try to give an instruction. And one instruction may not be enough to perform all the operations what we are intending to do. So we write set of instructions. That set of instructions is known as a program. So what is a program now? A set of instructions to perform a task is known as a program. Okay. For example, your washing machine does a job of washing your clothes, right? So there is a program already built in. You put your cloths inside and you press the buttons for water inflow and other things. Automatically it will calculate how much water is needed, and then so much of water is taken. It will also calculate how much time is needed to finish off the task. Once the task is finished, it will give a buzzer or alarm sound to you, say that the task is over. So a set of instructions has been written so that the work can be completed. Similarly, whether it is traffic monitoring or any other real-time job or any other real-world application you can think of is done with the help of a program. It is independent of any kind of the applications what we think of. Okay, it is useful for agriculture, it is useful for healthcare, any kind of illustrations you can do for writing a program. Now coming to that instruction and program, just now I said a student will be asked to stand up in a class to answer a particular question. So I need to issue a command. So that command has to be in a language which the student can understand. For example, now I'm speaking in English. So if all of you are able to understand English, I can give this command in English. Or if most of you know Kannada, I can tell in Kannada also. So it means that particular audience should understand the command in the language what the audience know. Similarly, for the computer also, we need to give instructions, or we need to give the commands, or we need to write the programs in a particular language, not like the human language what we are speaking, like Russian or Japanese or English or whatever. So we need to develop certain set of languages to write this particular program. So those languages which the user will use are known as basically high level languages. We will discuss that again later, just to understand the concept about this. So you need to give a command, and command should be in a particular language. Okay, so that you should remember now for the time being. Then what is software? A set of instruction is a program. We said just now, a set of programs constitutes a software. Okay, together, a set of programs constitutes a software. So there are two types of softwares: application software and system software. We will discuss this also in detail a little later. Okay, so basic two words which you are supposed to understand now is, one is hardware, other one is software. So hardware is the physical parts of the computer to make your job easier, to give the input, to visualize the output, to store your data, so all such things. Software is the one which actually runs the hardware, in the sense the programs or the instructions what you write in the language will be applicable to those hardware what is already available in the computer, and they will be working as per the software or the programs which you are writing in a particular language. Okay. Now coming to the next terminology called as data. Data are nothing but the operands for your operations. For example, if I say evaluate y equal to mx plus c, a simple mathematical straight line equation, which you already studied, right? So I need to give you the data, what is m, what is x, what is c. In mathematics, of course, on pen and paper, it is easy because you can write everything as a graph also there. But in writing a program, I need to use a particular language. So I need to provide the data appropriately as per that particular mathematical or logical operation. So those are the operands used by the instructions. Okay. Then what are the data representations? Now the data can be in any form. For example, I'm speaking now, which you are hearing. So the speech is a data to you. So my video or image is available. That is also a type of data to you. I'm typing something on this particular screen now. That is also a data to you. So that means data can be in multiple presentation formats. So data can be like text, like your alphabets, alphanumeric characters like this. And our data can be in the form of an image. For example, you use WhatsApp and you can send images and then the data can be in audio. You can record a song and then play it, or record a song and send to somebody. That's the data. Or you can record your video and send to somebody. So there are multimedia data, which is generally called as now audio, video, speech, image, voice, etc. all together. Earlier, of course, we had only text type of data, and each type of such data, text or image or audio or video, has what are known as formats to represent. So just try to write here formats. There are standard formats to represent. Hope it's visible. Formats, yeah. So there are standard formats to represent data. For example, earlier text data was used with ASCII code or ASCII format. All text data on your keyboard, for example, suppose you press A there or B there or key C or something like that. Each of that letters A, B, C will be having a ASCII code, generally called as ASCII code, CODE code. Okay. So later they developed Unicode also. Then for images, you have basically, even you can take in your camera or whatever you have stored in your mobile phone, you can go back and check. So different types of formats: GIF, PNG, photographic format, graphics interchange format, JPEG, etc. And then coming to audio, like you record a song or whatever it is, or record your voice in WhatsApp and send to somebody. So you can be in MP3 format or ARC format, advanced audio coding format, etc. Similarly, your video in MP4, AVI, dot wave or whatever. So each of those kind of data are represented using different formats. That's very important thing. And one more thing to remember is each of this type of data requires different amount of memory. For example, text requires less memory compared to image, and image requires less memory compared to audio, and audio requires less memory compared to video. Okay, so this is how we try to check all these kinds of data formats. This is just for illustration in the beginning. So whenever it's required, we'll try to go ahead with it. Otherwise, this will be useful for your other subjects as well when you study. Okay. Now we'll come back to the definition of processor once again, because that is, as I said, is the brain of the computer, which does all the computations. So we should really know something about this particular CPU. Earlier, I told about the computer, which has 4 functional parts: input unit, output unit, memory, and CPU. Now I'm talking about only CPU, the processor. Okay. So which is referred to as microprocessor or CPU or processor, which is a programmable digital logic device built in one single VLSI chip, which can perform various operations as per the commands or the instructions given by the user. This is a very technical definition. I know at this level it is difficult to understand what is VLSI and all. This is a manufacturing technique. Just remember like that. Very large scale integration. ENC students, you will anyway study this in the higher semester. This particular subject, very important subject. Okay. So this is, as I said, like IC. I said earlier, if you remember, I used the word IC, integrated circuit. So you can just think it looks something like this. We will show the diagrams in the later classes also. You can just think of it as a rectangle kind of a thing, a device with some pins on either side, something like this. And this pin is a conductor of electricity. So you can apply some voltage to this, and then, or if you do not require that operation, you can as well put it to a ground level. So basically it is a 2-level logic, in the sense either you apply a voltage or you apply 0 voltage, something like that. Okay. So this is an IC. So what is inside this is this. This is CPU. Let us assume CPU is like an IC like this now. Okay. This is the CPU. So what is inside this CPU is like this. Okay. So inside the CPU, you have 3 major portions: ALU, okay, then you have registers, then you have C, control unit. This is this. So 3 important functional units of a CPU. Okay, please remember that. It's a hardware. So one is arithmetic and logic unit. Just now in the beginning, I said that basically we are computing like y equal to mx plus c, some mathematical operations like that, or some logical operations. Logical operations are those which are like decision making. For example, to decide that whether the fan should be on or not. The AC should be on or not. Something like that is a logic. And to store the data temporarily inside the CPU, you have something known as a register, register, register. And when I say register array, it means there is more than one register. That's it. And all the operations of this CPU and everything is governed by something known as a clock. I'll just try to write here CLOCK, just like the clock in your house or clock in your mobile or in the watch what you are wearing. So for example, if I'm taking this class at say 9 a.m. in the morning, at 10 a.m. we will have a different class, right? For a different subject. So that means there is a timing for the operation. Similarly, for CPU also, the timing has to be maintained. Which operation is being carried out at what time? So that is referenced with respect to this particular clock. Okay. So what is the property of a clock? I'll just explain here only so that when you go to the next topic, you will try to at least recall this again. Okay. So a clock, one major property of a clock is it must be having two stable voltage levels. So I'm just showing it as a signal or a graph for you to understand. Okay, let us say this is some plus voltage and this is some zero voltage. So you can see either it is staying at zero voltage or it is staying at 5 volts. Okay, so this kind of a signal we call it as a digital signal. Okay, which is discrete in amplitude and discrete in frequency or time. Second thing is the clock has to be periodic. Periodic signal, you know, which repeats itself, right, after a certain time interval. So there is a period of the clock. So this is called as period of the clock. So what are the two properties of a clock now? The first one is the clock must be having two stable voltage levels and it must be periodic. And from physics, you know the relation between the frequency and the period, right? The frequency is inverse of the period. So that means if the period is more, frequency is less. And if the period is less, the frequency is more. So that is why when you buy a mobile phone or computer, we look into the clock frequency, like, right? So like, for example, I have a clock frequency of say 1.8 gigahertz. Frequency is measured in hertz, as we all know from physics, right? Cycles per second. So as the frequency is higher, it means the time period is lesser. So it is more preferred because you can perform more operations within a given time. That is how this particular thing works out. So this is basically the initial session, what I would wanted to discuss with you in the first session of this particular module. And there are some questions I'm trying to put for you to understand and then go to the next one. So there are some multiple choice questions for you. Of course, I have given the answers at the end. You can as well go through that just to test your recall of this particular topic, what we discussed. Simple thing, for example, what is CPU? CPU stands for. And now from the discussions we had so far, you can easily answer this question. It stands for Central Processing Unit, something like this. Similarly, which of this is not an input device? So there's a kind of, recalling all your topics, whatever we discussed till now. So there are some 10 questions like this. Of course, answers are also given at the end. So you can go through that and then try to learn the subject in a better way. Okay, thank you all. So we'll move to the second session later. Thank you.